Good afternoon, everyone. So it's me, Prince Rai, and in this lecture, we're gonna talk about the structure of plasma membrane. So talking about the plasma membrane first, we need to know the concept of animal cell, right? So when we talk about the animal cell that you are looking right over your screen, this is the animal cell that I have drawn here. So it is actually covered by a layer outside, and this layer is basically called to be plasma membrane. Okay, so the concept that you need to know, the outer covering of the animal cell is better considered to be the plasma membrane in simple way. And plasma membrane is also often called as cell membrane, right? And also called as cytoplasmic membrane or even plasma lemma. So these are the synonyms for the plasma membrane. So today in this lecture, basically we are going to focus on the structure of the plasma membrane. So the most accepted model for the plasma membrane structure is none other than the fluid mosaic model, right? The fluid mosaic model was given by Swinger and Nicholson. So they just claim that the structure of plasma membrane has basically the three components or the three composition molecular organizations, and those compositions which we are going to deal today. Okay, so now the three major compositions are, okay, what are they? Now let's study. The first one is the lipid, the second one is the protein, and the third one is the carbohydrates. Okay, now let's go into their molecular organization. Now, when I talk about the lipid, it is usually double layer. So basically, we refer it as bilipid layer. Okay, so it has got two layers, so we refer it as bilipid layer. Now, when we talk about the upper layer, this one is the upper layer, whereas this one is the lower layer. The upper end or the upper layer has got same composition or same structure. You can see over here, these circular structures are considered to be the head, whereas these structures that you are seeing downward is the tail. But when you look at the lower layer of the lipid, the tail are inverted towards upward, right? But these head are directed towards outside. So what is the reason behind this tail facing towards each other? Because you need to know that this is the outer extracellular environment, okay, extracellular environment, whereas this one is inside the cell, or we can consider it to be intracellular environment. And the point to be noted is that both extracellular as well as intracellular environment is aqueous in nature. It means it has got some water content in it, right? So the reason the tail part of that lipid is not facing outward, or let's say inward, towards the extracellular and towards the intracellular environment, is because it is hydrophobic in nature. Hydrophobic. So it means that hydro simply relates with water, phobic means fear. So it has got some fear of water. So it cannot be directed towards extracellular environment and intracellular environment because it has got some water content, or it's, let's say, it is aqueous in nature. So the tail are directed always towards each other, and the head is hydrophilic in nature. Hydro simply means water and philic simply means loving. So it is water loving structure of lipid, right? So this is actually organized in this way. Now let's talk about the protein, right? So when we talk about the protein structure, you need to know some point. I'm telling you just the basic points. Here are some additional points also you need to remember for the membrane transport principle to understand. But we are just dealing with the simple type of structures over here of the compositions. Okay, so you are seeing here, if I'm drawing here a layer, okay, if this is a layer, what you can see is that this layer is present on, okay, this is present on the surface of the layer. Okay, I mean to say it is present on the surface, right? Whereas this is partially embedded inside. It is partially embedded, whereas this one is completely embedded inside that layer, right? So what I am going to tell you is that these are the three kinds of protein. You will see the structure down there. So some kind of proteins is present on the surface and some kind of protein is partially just below that lipid layer, and some protein type is completely inserted, completely embedded inside that lipid layer. Okay, this is what I'm going to tell you. And this third one refers to the carbohydrate structure. Okay, carbohydrate structure, you need to know for the carbohydrate structure, you need to know the term glyco. Okay, for the carbohydrate to denote, we need to use the prefix glyco. So if the carbohydrate is attached with the lipid, it is better considered to be glycolipid. Okay, suppose let's say this one is connected with the lipid layer, so it is considered to be the glycolipid. But if this carbohydrate molecule is attached with the protein layer, so it should be named as glycoprotein. Very much concept that you need to know. So now this is the final fluid mosaic model structure of plasma membrane looks like. Okay, so what I'm drawing here is the lipid layer. Okay, lipid layer, and what I'm going to draw is some tails over here. As I already told, tails are hydrophobic in nature. Okay, okay, you can just draw along here the tail. I have not drawn all the kind of tails over here. Now, so these proteins that are on the surface are better considered to be extrinsic protein because they are outside. Okay, another thing is that these two, okay, I'm writing here 1 and 2, these are called intrinsic protein because they are inside the lipid layer. But this one is better called to be partial, or let's say partially attached intrinsic protein. This one is completely attached or inserted or embedded protein that refers to intrinsic nature. Okay, it is also inside, so we referred it as completely embedded intrinsic protein, or it has got some special type of name, that is tonal protein. Okay, tonal protein or transmembrane protein as well. So you need to know the concept behind this. So these tonal proteins are basically helpful for the facilitate diffusion. How it does facilitate diffusion, we will discuss it later on in the transport mechanism. So facilitate diffusion is performed by the tonal or the transmembrane protein. Now what you can see is here, these are the carbohydrate molecules that are attached with the protein. So better we referred carbohydrate with the prefix glyco, so we need to add protein here, so it is glycoprotein, and it refers to simply glycolipid because it is attached with the lipid layer. So this is what we're gonna talk in this lecture. So I have not taught about fluidity, why plasma membrane is better called as the membrane that shows the dynamic nature, and why it is often called as asymmetrical. I haven't discussed in this lecture, and also I haven't discussed the fluidity nature as I told you earlier, and also the flip-flop movement, what is the lateral movement, and where may be the cholesterol present here, and why the cholesterol is present in only the single layer of lipid. So that we're gonna discuss in the next lecture of our plasma membrane transport principle. So for today, this much only. So if you like the video, please do subscribe our channel, and also please do share this video to help your friends right over there. Thank you so much.